Hey y'all! So today we are looking at relations and functions. And this is very much like one of those situations that people always say, well, squares are technically rectangles, but not all rectangles are always squares. So that's a similar idea to relations and functions. Relations really is just any rule. It's just a rule that assigns an output value to each input value. A lot of times they're compared to machines. They do some operation to transform a number. Okay, and a function just follows a really specific rule. So it is still a relation. A function is a type of relation, but relations can sometimes give you two different answers. Like maybe I have a machine that transforms potatoes. I can put in a potato, that's my input, and then my output might be two different things. My output could be maybe it makes a French fry and maybe it makes mashed potatoes, right? Okay, so there's two different things that potato could turn into. A function is never going to turn it into two different things. A function will only have one answer for every input. So if I put in a potato, I get out a potato chip every single time. Okay, so in mathier terms, we can look at the definition that I've written down here. A function is a relation that assigns exactly one output to each input. We're not going to have any x values that repeat and give me two different y values. Okay, and once we decide that, we can see some examples of what is and is not a function, right? So here I can see that none of these x values repeat. I only have one dot for every single x value. Or in this case, if I were to make dots, none of the dots are directly on top of each other. Okay, versus over here to the right, examples of things that are not functions. Here I have an x value that has two different outputs. It has two different y values. So that is what makes this not a function. An easy way to check that with a graph is something called the vertical line test that's over here on the right. So if you draw a vertical line and it touches a graph more than once, that means that x value has two different outputs. And that's like the potato turning into two different things. We can't have that with functions. Okay, and as we look at these two different types of examples that we have here, you can see the top functions, we call them discrete. That just means that they are individual points. And the bottom two examples are continuous. That just means that the lines are connected. And you'll see up here at the top, I put a little star next to the word continuous. There's actually a lot more that goes into whether we decide a function is continuous or not, but for now, you just need to know it's going to be a nice smooth line where all the dots are connected. So dots being connected makes it continuous for now. Okay, so find the domain and range of each relation, good review from yesterday, and then we need to determine if the relation is a function. Okie dokie, so domain is going to be all of the x values. These are discrete individual points. So we have x comma y, x comma y, x comma y, right? You get the idea? So we need to list all of the x values. And I would prefer you do this from least to greatest, but it's okay. It doesn't really have to be. -1, 0, 4, 6. Oh, they already were from least to greatest. Okay, and then range, same deal. We're going to list all of the y values. The smallest is -9, and then -5, and then -2 and 3. And I can look and I can see the x values did not repeat. It's okay if the y values repeat, right? On both of these examples, here's a repeating y value. That's okay. We're allowed to repeat outputs, just like with the potato chip example. If I put in one potato, I get out maybe 10 potato chips. If I put in 2 potatoes, I get out 20 potato chips. It's okay if I get the same number of potato chips out. It's just I know the only thing I'm going to get out is just potato chips. It's not going to be 10 potato chips or 10 French fries, that would get confusing. Okay, so anyways, the x values do not repeat. So yes, it is a function. Okie dokie. Next one, domain. Again, we're going to look at all of those x values from least to greatest. We have -3, 5. 5 repeats, so I'm not going to write it twice, but that also means I already know it's not a function. That x value repeats. No, because, so this is something I write in the notes a lot. This is like from geometry, a little shortcut that means because. I think you probably in geometry see this one more. This one means therefore. Therefore. This guy is just short, so that way I don't have to write the whole word because every time, because that'd be annoying. Anyways, no, because 5 repeats. And actually, you know what? I want to make that a little better. I want to say x equals 5 repeats. Because like I said earlier, it's okay if the y's repeat, just not the x's. Okay, we still have to answer range though. So range are my y values, so I'm going to go in and y, from least to greatest, and we have -6, 0, 2, 4. Okay, here's a table, but same idea. Here are my x values as a list. And my range. And that is a function because the x's don't repeat. Okay, this is called a mapping diagram, but same idea. And is this a function? No. And that's because, oh, funny enough, it's x equals 5 again. X equals 5 maps to 2 different answers, which means that x equals 5 repeats. It's funny, it's x equals 5 again. Okay, on E, domain. So this is a continuous function. So this is more like what we were doing yesterday. This is where the x value starts. That's -1, -2, -3, -4. Range goes up and down forever. Okay, so this is one where maybe we need to use the vertical line test. If I do the vertical line test over here, it only touches once. Okay, but I can't just do that in one place. It has to be true everywhere. So if I look farther to the left, if I do a vertical line over here, it definitely hits the graph twice. So this is not going to be a function. Oops. No, because it fails the vertical line test. Okay, F and G, I do not expect you to do all by yourself. I do expect you to be able to graph this in your graphing calculator, which unfortunately I can't show you on this screen. But if you get out your graphing calculator, you press that y equals button at the top left corner. And on that first line, it already says on the screen, it already has y1 equals, and then below that, y2, y3, y4. But you just need to go ahead and type in -x squared plus 3. Make sure you type it in correctly. But then go ahead and click graph on the top right corner of your calculator. And you should see a graph that looks something like, let's see, -+3. It's going to look something like this. So you can see the picture of it. You should be able to see the little grid lines, and we can count 1, 2, it goes up to 3 right there. So the domain is going to be negative infinity to positive infinity. The range is going to be negative infinity up to that positive 3, which again, you should just be able to see on your calculator there. And if you need help with it, you can ask me. Okay, and is it a function? Well, yeah, it sure looks like it. No matter where I put that vertical line, it only ever touches the graph once. So yes, that is a function. Okay, G, I guess I kind of lied to you. You do have to do G kind of by yourself, because if you'll notice on your calculator, your only option is y1, y2, y3. There is no option for typing in x equals -1. So that's something that we need to remember from Algebra 1. And if you don't remember, that's okay. That's why we're reviewing it in the notes. If we just have x equals -1, that is just going to be a vertical line. And the way that I know that is because let's just go to, I can literally see x equals -1. So I know what the x-axis is. Let's go over to x equals -1. And what this means is I can have any point in existence as long as the x value is -1. So I'm just going to draw a couple of different points now where the x value is -1. Here's -1, 1, -1, 2, -1, 3. I could do -1, -1, -1, -2, -1, -3. And just by kind of working through that, just by knowing what x equals -1 means, I can see that that is a vertical line. So the domain is just -1 and only ever equals -1, but my range goes up and down forever. So my range is negative infinity to positive infinity. Is this a function? No, it sure isn't, because the vertical line test, it touches it more than once. It touches it an infinite number of times because it fails the vertical line test. Okay, function notation. So in Algebra 2 this year, in every single chapter, sometimes you will still see us use y, but most of the time we're going to start using function notation. So that's where we switch out the y for f of x is how we read this. Okay, and the reason that we do this is it does two things. It names the function. This is function f, or we can see in other examples on this page, function g, function, p, right? We can see a couple different examples of function names. So it names the function so I can tell the difference between them. And it also tells me what my input variable is. Most of the time we use x's, but you can see over here that sometimes we can use letters like t, especially if we're talking about time. If my input is time, 1 hour, 2 hours, 3.5 hours, I probably want to use t because that makes more sense than x in context. So what that tells me is this is the function h, and in that function, t is my independent variable or my input variable. Okay, and just the most common mistake that I see, and you have to just learn how to read these, is that this does kind of look like f times x. But that's not what this means. It is notation, it means f of x. I'm plugging in x into a function that is named f. Okay, so let's look at that in action. Use the following functions to evaluate problems A and B. So we can see I have two different functions, which makes it really nice that they are named, so I know which function to use when. Okay, so for this first problem, I'm using f, and I am going to plug in with parentheses -9 anywhere that I see an x in the original function. Okay, so I have -5x, but instead of x, I'm plugging in negative 9 minus 14, and you can go ahead and use your calculator for this. I unfortunately am still calculatorless, so I need to do this one in my head, which is positive 45 minus 14, and then subtracting that, what we get, 31. And feel free to correct me if I've made a mistake. Okay, for this next problem, there's a lot going on here, but what we need to learn is that no matter how complicated a problem is, mostly as long as you can just copy it back down and change one thing, you can slowly figure out how to solve it all by yourself without me having to tell you what to do. Okay, so looking here, I can see G, right? So that's the thing that I'm going to change. I'm not even going to worry about what the heck does this 2 mean. I don't know what to do with this 2. That's okay. I'm just not going to do anything with it. I'm not going to disappear it. But, but I am just going to copy it down. So 2, bracket. Okay, but then I know what to do with this. This means I'm using the function g. I'm going to plug in a 12 in parentheses anywhere I see an x. This negative does not go inside the parentheses. That negative is just in front of the x, so it's going to go negative, plugging in 12, 12 plus 9, and then I have another x, so parentheses 12 minus 1. Okay, so I took care of this. This is the part that I chose to change in the problem. So then I still have this parentheses at the end. And even though I had no clue what to do with this 2, now that I've rewritten the problem, now it really just looks like it's multiplication. It's 2 times whatever this ends up equaling. Negative 12 plus 108 minus 1. 2 times, and you are more than welcome to type this in your calculator. However, if you do type it in your calculator, there is a bracket on your calculator. You do not want to use that for multiplication. You want to change these to parentheses if you're typing it in your calculator. So if you chose to type it in at this point, it should have looked like 2 parentheses negative 12 plus 9 parentheses 12 minus 1 parentheses. Okay. But I still have to do this in my head. So minus 13 minus 3 is 105. I think that's 95. And 2 times 95 is hopefully 190. Woo! Okay. Example 3. Use the function f of x equals 3x plus 19 to evaluate problems A and B. Ooh, interesting. This gives me function equals 34, and I'm solving for x. But again, even if you have no clue what to do, the best thing you can do is just copy everything down. Don't randomly put things places. Don't try to do some math magic. I can match things and substitute. I see f of x, so I'm going to replace this exactly with this because it says that those two things are equal. So I end up with 3x plus 19. This is the part that I just replaced. So the part that I didn't change was this equals. This equals 34. So again, even if you had no clue what to do to solve this, just by replacing something with something that's equivalent, not anything like switching places or putting random things random spots, it's just using substitution, then I can go through, subtract 19 from both sides, 9, 5, 15, x equals 5. And I can check that by plugging it back in. 3 times 5 is 15. 15 plus 19 is indeed 34. So I know that that's the right answer. Okay, so I'm going to do the same thing over here. F of x, I'm going to use substitution. and just replace that with something I know is equal, and then I'm just going to copy down the rest. Equals negative 62. There we go. Okay, Miss Skelton paid a landscaping company $108 for lawn treatment, $74 per month after, but then it just gives me that function. So a good ACT strategy is, normally you don't have to read the story part of the problem. If you can glance through and see an equation, you probably don't need the rest of the information. Okay, find P of 24 and explain what this represents. So maybe I will have to go back and read the context, but P of 24. So I am replacing the T with a 24 now. So 108 plus 74 times T. And I am going to see if I can't pull this up because I don't have a calculator, and these are kind of big numbers, aren't they? Okay, if we type this in our calculator, we should get 1884. Okay, and then we have to explain what this represents. So it tells me the function P of T represents the total amount of money she will have paid after T months. So Mrs. Skelton will have paid $1,884, but we need to make sure, like, where did that number come from? It's not just that she paid $1,884. I got that by plugging in 24. So that much money after 24 months. Okie dokie, if Ms. Skelton has paid a total of $2,994 to date, how long has she been receiving lawn care? Okay, so again, this is my total. So I'm going to go ahead and set the function equal. I'm going to go ahead and say 108 plus 74. I don't know how long, so I'm going to leave that a T, but that equals 2,994. And unfortunately, this is not one that you can just do in the calculator. You do need to, well, you can do the math, you just can't solve the whole thing all at once. Subtract 108 from both sides. Divide both sides by 74. So how long has she been receiving lawn care? That is 34 months. And that is the last lesson of Chapter 0. So happy